All right. Okay. Assalamualaikum and a very good evening to all of you. Selamat Hari Raya Aidil Adha. Okay. So we are in week 14 now, minggu terakhir. So next week will be our revision week, and then we going to have our final exam, final assessment on the 31st, isn't it? Saya dengar ada juga yang repeaters tu yang kena pagi tu ada high voltage Siapa yang terlibat?
Ya, doktor.
Betul agak
Ya.
keras jugalah So pagi high voltage and then 2 petang kena ada polytronic. So you have to make a proper preparation for ahead, and insyaAllah you'll do great insyaAllah So kita ada hari ni saya akan complete the lecture. Ada satu lagi topik sebenarnya yang akan masuk dalam final lah. Senang cerita straight to the point. That will be in the final exam and final assessment, which is not covered in the video, right? So I'm going to look into that particular topics, and then inshallah next week I'll try to have one session, probably one video, to do some revision and to look into the what we're going to expect in the final assessment. Some of the area, some of the topics that you need to focus on for the final assessment. Right, so no worries. I'm going to record this session as always. I'm going to share with you. Okay, so on the switch mode inverter, by the way, for the test 2, the pass rate is about 50%, 70%, 60%. 60% yang pass, another 40% yang fail. So I hope you can do best on your final assessment, right? Hari ni juga nanti malam ni saya akan share apa dia punya solution, right? And please look into that. Okay. Alright. So on the switch mode inverter, we have inverter is a AC DC to AC. Okay, it's a straight way AC DC, which normally we apply to the solar panel, solar PV system, whereby the output from the solar panel will be in the form of DC voltage, and then you need to have this AC inverter. I mean, this inverter to convert the waveform from the DC to AC to suit the load requirement. So the load is, of course, it is in terms of AC. Therefore, we need to have some converter that can convert the AC and the DC. The DC is always, if we can remember, the perfect DC voltage is a straight line, isn't it? It's a straight line. We have a DC voltage, and then how can we shape that straight line, a constant value DC voltage, into an AC periodical repeating waveforms? Okay, of course, the most beautiful AC waveform is the sinusoidal waveform, isn't it? But sometimes it is enough, it is sufficient for you to have a square waveform at the output, as long as it is periodical. It has a period. I mean, it has a frequency of repeating rate, right? So it can be a square waveform. It can be a quasi square waveform. It can be a PWM waveform, isn't it? As long as it has a period, it has a frequency of repetitive frequency of operation. 50 hertz, of course, we need to have a 50 hertz main frequency of output, because normally our load will require a 50 hertz operation, isn't it? Or waveform. So we have 3 output, square wave output. I hope by now you have about 70% watch the video. Okay, please, the video is there, and you have to you know, wash it twice, 3 times, as much as you like it. All right, as long as you understand the explanation, right? Okay, so we have the single phase inverter, square wave output. With the same circuit, we can have a square wave output and quasi square waveform. And finally, we also have this PWM switching scheme. We have a SPWM, sinusoidal PWM waveform. Okay, there are two types of PWM. The first one is unipolar and the other one is bipolar. So you need to differentiate between unipolar PWM and bipolar PWM in terms of how to generate that the signals to all switch, to both switches here. That is most important. Senang je, kalau unipolar you requires two comparator here, isn't it? Kita ada dua comparator. Kita mesti ada dua comparator here. Comparator 1, comparator 2. And then the first comparator, we're going to compare a sinusoidal, a conventional or a normal sinusoidal waveform with a triangular carrier with positive only values. Betul tak? Ingat itu je. That is a unipolar PWM. That's why it's known as unipolar, because the triangular carrier signals only consists of positive values. So that is unipolar. Jangan confuse yourself. Don't confuse yourself. So, and then what else? So we have this as a VC. Right, this is VC, and this will be your VM, isn't it? Okay, carrier modulating signal. C stand for carrier, M stand for modulating signals. So compare. Whenever VM greater than VC, it will create a pulse of 1. Itu je. Rules dia itu je. Bila mana VM greater than VC, dia akan keluarkan pulse 1. Bila mana VM lower than VC, it will have a 0 level. So dia akan switch balik ke situ. Kosong balik. 1, 0. Switch on, switch off. Okay. So, kalau you tengok sini, daripada sini, zoom balik, boleh zoom tak boleh. Okay, kalau daripada sini ke sini, VM is lower than VC. So dia punya pulse tu is actually at 0 level until dekat sini sampai sini, isn't it? Ini bila mana VM greater than VC. So you can see the pulse generated after the comparator. Okay, selepas comparator ni, kita ada comparator ni. Selepas dia, mesti ada pulse. Sebab VM greater than VC. This is rule number 1. Okay, so yang seterusnya lah. Seterusnya. Itu unipolar PWM. So, bila sampai dekat negative half cycle, sebelah sini, apa jadi? VM is always lower than the VC, isn't it? So, you akan nampak pulse ni dia sampai half of the cycle. And then sini dia akan off. Sampai sini dia akan on balik. That is the nature of the pulse signals for unipolar PWM. Okay, itu yang switch untuk switch 1. Right, untuk comparator number 1. Untuk comparator number 2, dia terbalik. Dia punya sinusoidal signal inverting version of the first one here. So instead of the normal sinusoidal signal, dia inverting version of the sinusoidal signals. And then we still compare with the same triangular carrier signal. Sama je. Triangular carrier dia satu. Sama. Yang sama. Okay. So you akan dapat di sini off, isn't it? Sini off, apa dia, and then sebelah ini baru you nampak dia punya pulse. Okay, so you'll be able to recognize even unipolar ke bipolar. So itu unipolar. Ini saya cerita sebelum saya masuk ke topik yang saya nak bincangkan hari ini, akan masuk dalam final exam. Okay, so unipolar PWM. Kemudian tengok sini. Right. I think the video, the note is self-explanatory. You baca betul-betul, tengok betul-betul, insyaAllah you akan faham. Jadi, okay. So ini, nampak tak? Ini signals to the switch. Signal to the switch only. Bukannya output voltage. Output voltage kita tengok balik. Bila mana switch 1 on, apa jadi? Switch 2 on, apa yang terjadi ke output voltage. Right? Switch SPWM1 dan SPWM2. Okay. Right. Ini yang untuk second comparator. Nampak? Dia punya sinusoidal signal, dia inverting version, compare with the same carrier signal, positive value, and then ini dia punya control signal dia. On off, on off, on off. Tengoklah. Bila mana VM greater than VC, you will have the pulse. Kalau you boleh tengok sini, pulse ni dia akan luas sikit, besar sikit dia punya width. Okay, because VM greater than VC, dia punya width dia besar compared to yang dekat hujung sini ni. Kalau you tengok dekat hujung sini, very small, very tiny width, isn't it? Itu yang kita nampak, dia punya pulse kecil je kat situ. Okay, itu dia. Right, then baru kita ada dia punya output voltage. This is the output voltage. Output voltage je senang je. Tak payah pening kepala. So you have input voltage plus minus V in. Then you have, let's consider the half bridge first. Tak kisah apa dia punya switch can be on the left or on the right. Then we have a capacitor, and then we have the load at the center here. So this is S1, S2. Right. So when S1 is on, apa akan jadi? Sini because it's a half bridge, so this will be half of the V in, isn't it? V in. Then kita ada half V in kat sini. Okay. So whenever switch 1 on, switch 2 is definitely off. So kita ada buat jalan through here, and then come back to there. Jadi, so V out dekat sini plus minus akan jadi positif V in, ada half V in kat sini, so sini pun sebenarnya ada plus minus half V in kat sini. Jadi, sini plus minus half V in, so kalau kita tengok sini 50 volt kat situ. That's why it's half, because kita punya ni 100 volt input dia. So dia ada 50 volt kat situ. So and then whenever S2 on, S1 off, S2 on, so dia akan terbalik pula. Dia akan pergi ke sini, and then negative, dia masuk ke negative sini, then through S2. So that's why you have a negative value. Right? So by now you should recognize between, you boleh differentiate. You can differentiate between unipolar PWM technique or bipolar PWM technique. Daripada tengok je dia punya output voltage. Okay, this is unipolar PWM. Remember, AC voltage dia tak perlu cantik ada sinusoidal waveform. Right? It is enough that the voltage is repeating. Apa tak? Dia kan kalau you tengok yang PWM output voltage ni, dia repeating. Jadi sampai sini dia punya one cycles. This is first cycle, and then sini jadi second cycle. Great. First cycle, second cycle. So macam mana nak dapatkan dia punya fundamental 50 Hz, kita buatlah dia punya fast Fourier transform tadi, FFT. Kita dapatkan dia punya Fourier transform. Okay, Fourier kata apa? Any waveform is actually made of a combination of sinusoidal signals, individual sinusoidal signals at different frequency with different amplitude. Alright, itu je. So, bila kita tengok dia punya FFT, tengok dia punya spektrum, ini yang kita nampak. Jadi, kita ada load. Ini frekuensi 50 Hz. This is at the frequency 50 Hz. And then we can also identify, kita boleh sebenarnya cari apa dia punya peak ataupun amplitude by using this equation. Modulation index, okay, modulation index multiplied by half of the V in. Half sebab half bridge. Okay, kalau you operate with a full bridge, then dia akan jadi MA multiplied by V in. Itu ada dalam video. Right? Itu ada dalam video. Tapi saya just nak revise balik. Sebelum saya pergi ke detail. So, sekarang ni, okay, itu dia dipanggil unipolar PWM, and then we also have this bipolar PWM. Nampak? Ini bipolar PWM. Okay, kalau bipolar PWM, you cuma ada satu je comparator. You only have one comparator. What you do is you compare the same the sinusoidal waveform modulating signals with the triangular carrier signals. But now the carrier signals consist of positive and negative values. So this is the normal what we call it as a triangular carrier signals. Positive, negative, positive, negative. Alright, triangular carrier signals with a frequency of 1 kHz, for example. Okay, so they operate with 1 kHz. Right, so sama juga dia apply whenever Vm greater than Vc, it will create a pulse of 1. So that's why dekat sini dia ada pulse 1. Kalau close to the peak of the modulating signals, the pulse become wider. Look at that. The pulse become wider. Luas lah. Makin luas lah. Wider. Luas. Sebab apa? Sebab tengok dia punya Vm greater than Vc is higher than the rest. Isn't it? Wider than the rest. So that's why we have a... So ini kita tengok pun kita dah tahu dah. This is bipolar PWM. Bi. Sebab bipolar tu pun kita dah tahu dah. It's positive and negative. Dia ada positive and negative values. So, ini dia punya sinusoidal PWM. And then untuk switch yang lagi satu, kita cuma apa? Inverting version. Kita dapatkan dia punya inverting version, the mirror image of the first sinusoidal signal. Ya, the first PWM signals. Itu yang dalam simulation ni kita ada inverter. Right? That's why we have this inverter. The invert. Right? It inverts whatever the signals that you have. So that's why kat sini you ada inverting version. Inverting version of PWM. So ini yang akan supply kepada PWM satu lagi kepada switch satu lagi. Right? So you just focus on kata di sini kan. Okay, just focus on that. Just first leg. So S1 yang akan terima the first PWM tadi. S2 akan terima the inverting version of whatever control signal for S1. So dia sebenarnya dia kena elakkan S1 and S2 untuk on sekali. Dia tak boleh simultaneously on S1 and S2 at the same time. Right? Because if you turn on S1 and S2 at the same time, what happen is, if you think about this will be short circuit, isn't it? This will be short circuited between that point to that point. So what happened? The voltage, the supply voltage is actually has been short circuit, isn't it? So there will be a large current flow outside of the source, and that's why it will damage all the switches here. right? So we don't want that to happen. So in practical, dalam practical, dia ada dead time. Dipanggil dead time. So kita tak discuss lah di sini. Kita tak discuss lah di sini. We're not going to discuss that here. So in practical, there is a dead time. Maksudnya dead time apa dia? Dia ada it allows this to turn off, and then dia akan wait for a few seconds, few microseconds before SPWM1 turn on. Jadi antara ni dua ni dia ada dead time, maksudnya dia ada dead time. Maksudnya ini off. Okay, ini off. And then there is a dead time before turn on switch 1. Okay, so this is switch 2, this is switch 1, for example. Okay, and this is known as dead time. Okay, to prevent a short circuit to the supply voltage where a very high, huge current will flow that damage all the switches. Okay, so by now you hope you can differentiate, right? So this is the output voltage with the bipolar PWM. Apa tak? Beza kan tadi kan? Right? Beza sangat. Isn't it? Dan betul lah, kalau tengok ni apa waveform ni tak nampak langsung dia punya sinusoidal tu jauh lah kan, isn't it? Tak nampak bayang pun mana sinusoidal AC waveform ni, tapi sebenarnya kalau you tengok closely and if you look at the FFT, fast Fourier transform, you look at the harmonic spectrum of that waveform, this is what you're going to see. You akan nampak ada fundamental which is at 50 Hz and the rest is harmonics. Okay, so bayangkan kita ada filter, low pass filter, which means you just pass the low frequency and you attenuate ataupun you delete or you remove the high frequency components. So what apa yang jadi bila you remove this? Maksudnya selepas ada filter tu, what happen is, okay, let's say kita ada filter, we add a filter here, add filter. So selepas filter ni dia akan jadi a nice sinusoidal signal. Saya rasa dalam video tu ada yang saya tunjukkan, ya. Bila kita letak filter, hilang dia punya high frequency tu. So apa yang kita nampak is just a sinusoidal signal, the fundamental component, right? So nanti okay, jadi it is important for us to find the value of which is the MA multiplied by V in here. Okay, ataupun sometimes dia nak tunjuk ataupun kita nak tengok macam mana kita boleh dapatkan menggunakan first Fourier series equation. Macam mana kita boleh gunakan Fourier series equation to solve this waveform. Ingat lagi tak Fourier series equation? Ingat tak? Kita ada apa? Yang AN equals to, ingat tak? Then we have BN equals to, saya pun dah lupa dah. Ingat tak? Kita ada apa? F of T, any equation equals to A naught over 2 plus summation of n from 1 to infinity an cos n omega t plus bn sin n omega t. Is that it? AN cos omega t plus BN sin n omega t. Okay, and then kita boleh cari lagi AN equals to 1, no, 2 over T. Ini kena sentiasa ni fast Fourier series ni saya selalu tegaskan. Kalau dalam kelas face to face tu memang tiap-tiap kali ni saya saya akan remind what is the Fourier series ni, sebab kita akan gunakan Fourier series selalu dalam power electronics. A 2 over T and 0 to T, then we have 1 f of T cos n omega T dt. F of T cos n omega T dt. And then we have Bn 2 over T 0 to T f of T sin n omega T dt. And finally, Cn is equals to An squared plus Bn squared, which is finally f of T can be also represented by A naught over 2 plus the summation of n equals to 1 to infinity Cn cos of sin. Allah Akbar. Cos n kan Cn sin n omega t plus Pn. Okay, this is possible. So kita akan tengok. Saya cuba, kalau tak ini pun saya akan buat video sekali lagi. Kita tengok balik. How can we get the C1, C1, C3, okay, C5 macam mana? Daripada equation ni untuk signals bipolar PWM. Macam mana kita nak dapatkan? Okay, daripada tu. Alright, itu fokus fokus. Kalau tak sempat hari ni saya akan buat video detail lagi on how to solve that. Okay, so we load, right, and ini ni kita nak dapatkan apa dia value dia. Betulkah value dia ini 0.8 multiplied by 100 ataupun MA whatever the Morrissey index. Morrissey index simple je. Morrissey index MA is always Vm peak divided by V carrier peak. Vm, the modulating signal peak, divided by V carrier. Berapa dia modulating signals peak value dia, and then the carrier signals peak value dia. That will determine the modulation index. Right? Okay. So itu fokus kita kita nak tengok macam mana. Okay, right. So now kita dah faham ada unipolar PWM and bipolar PWM. Okay, so sekarang ni how in simulation senang. Kita ada comparator ni je. Kita ada comparator and then cuma kita masukkan signal, sinusoidal signals, and then kita masukkan the carrier signals. Ini carrier signals carrier signals, dan ini digunakan untuk shift. Ingat tadi tu macam mana kita nak shiftkan, sebab carrier signals ni dia akan tak silap saya dia akan keluar generate unipolar type of carrier signals. So kita kena shiftkan dia ke bawah. That's why kita ada minus voltage ni. So kita kena ada DC offset. Kita kena tolakkan ini ke bawah, baru kita akan dapat macam tu. Kita kena tolakkan dia separuh ni. That's why we have this voltage VDC here. Voltage ni ada summation, okay, plus minus tolak kan. So you shift ke bawah, ini you dapat 0 kat sini. Tadi 0 kat sini. Asalnya bila keluar daripada carrier daripada triangular source ni, dia positive waveform. Okay, so you kena switch, you kena shift down or DC offset. So kita second bawah, then we have this plus minus, right? Okay, so itu dalam summation. In practical, sebenarnya kita kena calculate macam mana nak dapatkan ini. Kita kena calculate, betul-betul calculate macam mana nak dapatkan point-point ni. Kita tahu ini 250 degrees, isn't it? Theoretically, this is 360 degrees, kita tahu. Right? Tapi, boleh tak kita kira apa ini degree untuk this one, theta 1? Tahu tak theta 2 berapa? Okay, theta 1, theta 2. Tahu tak sini theta 3 berapa? Theta 4 berapa? Okay, theta 5 berapa? Tahu tak? Sebab kalau kita tahu apa ni, ataupun there is a equation to describe all these theta 1, theta 2, theta 3, 4, we can have this algorithm, we can have this programming. So kita tak perlu pun guna gunakan dia. Kalau dalam in practical, you kena cari IC comparator, you kena cari generator, sinusoidal generator, and then you kena cari triangular generator ataupun IC, and then you compare. Okay, tapi nowadays we have this programming or microprocessor. So this microprocessor, if you can provide it with the equation for theta 1, theta 2, theta 3, 4, 5, you can create this pulse without having all the ICs. Comparator, we call it a discrete IC. Kita tak perlu beli komponen IC, comparator apa semua dah. Kita cuma ada microprocessor tu, right? And then we program, and then we just generate this pulse. Okay, generate this pulse. So, and therefore, that's why the final lecture is on detailed analysis of PWM. Okay, detailed analysis of PWM. I have shared this through the WhatsApp group. Okay, the last final lecture here. Right, so actually it requires a fundamental in y equals to the straight line equation. Y equals to mx plus c, isn't it? So if you have a line, a straight line, okay, we know what is c. The x-axis, the cross, I will call it the y-axis crossing point, and if you know the m, the slope of the, if you know the slope of that line, then we can create the equation, isn't it? Y equals to mx plus c. For example, y equals to half x plus 2, for example. Great. Okay, so that's what we need. And therefore, the first is unipolar SPWM. Okay, this is the unipolar PWM. So, we start with this is known as unipolar wave W shape. You kena tengok juga, dia ada W shape, nanti you kena pelbagaikan. This is known as W shape unipolar PWM. Okay, because there's also sometimes you could have this M shape. Kan ada beza tu. Sorry. You still have the same sinusoidal signal, right? But then look carefully. There is a different point now, isn't it, between W shape M and M shape waveform. So you have to be careful. So in this example, we only show you the W shape, right? W shape. Okay. So, right. So we start with here. This is the waveform, and that will be the period, isn't it? 1 Fc equals to, Fc is the carrier signal's frequency, 1 over Tc. So let's say this from there to there is the Tc, okay, and this will be the theta 1, theta 2, isn't it? But now we start with, we showed examples in terms of time instead of angle. Okay, so we have Tn1. Tn1 is the point, what we call it, the intersection between the triangular carrier signals with the sinusoidal signals. This is the first negative slope. That's why it's known as Tn1. This is a negative slope, isn't it? So that's why it is known as Tn1. Okay, and the next point, which is that one, happens at the positive slope. This is at the positive slope. So that's why you have this TP1. This is very important. You have to define carefully the N1 and P1. That will be different if you have an M shape, isn't it? I'm going to let you uh, uh, to to have a look at what happens if you change that to M shape. Of course, there will be different TN1, TP1, which is different slope, isn't it? Yeah? But I'm not going to. We just focus on the example here first. Right? So we have TN1, TP1. Then now this become TN2, the second negative slope line. Okay. Remember, this is always a straight line, isn't it? This is a straight line there. This is a straight line there. All of these are a straight line. You can think of the triangular carrier signals here. It is always a straight line there, isn't it? It's always a straight line. Okay, right. So therefore, once you have this Tn1, Tp1, Tn2, Tp2, Tn3, Tp3, now you can generalize. You can generalize, which means if the intersection falls on the negative value, negative slope, then it becomes Tnk plus 1, and if it's a positive value, it will be Tpk plus 1. Right? Okay, so that's some introduction, and then we start analyze with the first negative slope, which is that particular line here. The first negative slope line, straight line. So dia punya equation is cos y equals to mx plus c, and then the m, right? So kalau you dapat betul-betul dia punya m is ini TC, so this is half, isn't it? Kalau you tengok betul-betul, kalau you break into 2 here, okay, so this is 0.1, sampai sini is 1, and from there to there is TC over 2, isn't it? This is TC over 2. So M is always delta Y divided by delta X. So delta Y is 1, delta X is TC over 2. Yeah? So that's why we have minus, negative, because it's a negative slope. So we have negative 1 over TC over 2, and finally the M equals to minus T2 over TC. Okay, and therefore we go down, and then to complete the equation y equals to mx plus c, we know that at y equals to 0, x equals to tc over 2. So just referring to this particular point, tengok point ni je. That point, kalau kita buat coordinate, this is tc over 2, y dia is 0, isn't it? Okay, that's the point. So that's why in this equation we have y equals to 0, x equals to over 2, and therefore if you complete this equation, put that information into this y equals to mx c, you can find the value c equals to 1. Okay? C equals to 1. And therefore, now we have an equation, right? Therefore, kalau kita buat equation, dia akan jadi y equals to minus 2 over tcx plus 1. Based on these findings, we have y equals to 2 over tc. This is the equation to describe the first negative slope equation line. Okay, right? Or in time domain, kalau kita tukar dalam time domain, y and 1. This is known as y and 1 of t equals to minus 2 over tc. X akan diganti dengan t z plus 1. Okay, I hope you got it. And then we proceed with the first positive slope. Right, so this is a positive slope. Y equals to mx plus c. Sama juga. Kalau you ukur betul-betul, you akan dapat m dia 1 over tc over 2. And then if you look at this, the same point here, you can use the same point there to complete the equation. Therefore, you have minus 1 for c. And therefore, your equation becomes y equals to 2 over tcx minus 1. So, you akan dapat the next equation is that yp1. Okay? Right. Next, kita buat satu lagi. Second negative slope. So, you pergi pula dekat second negative slope dekat sini. Look into this particular negative slope here. Sorry. Second negative slope yang ini. Betul tak? Itu. That is second negative slope. I hope it's self-explanatory. You tengok balik. Okay. Sama je. You cari, you dapatkan dia punya M, dapatkan dia punya C, and then you akan dapat equation dia. Y and 2 equals to minus 2 over tct plus 3, and then for yp2, second positive slope, you akan dapat yp2 to c over t minus 3. Therefore, thus from the above equation, we can generalize the equation as daripada, so you buat satu, 2, 3 lagi, okay, you akan dapatkan pattern, and you can generalize the equation. You akan nampak that the equation for negative slope line will be equals to 1 over y and k plus 1 minus 2 over tct plus 2k plus 1, and then for the positive slope it will become 2 over tct minus 2k plus 1, and k will be from 0, 1, 2. So kalau you nak cari y1, so k, yn1, therefore k should be 0, isn't it? Kalau you nak cari yn3, k should be equals to 2. So you masuk dalam ni, and therefore you akan dapat, kalau you masukkan yn3 t equals to minus 2 over tc t plus 2 multiplied by 2 is 4. 4 plus 1 is 5. 5 is 2. Okay, and so on so forth. So, ini dia punya general equation. Untuk line tu, dia ingat, line, line, line. Dan kita ada line sini pula. Jadi, triangular characteristic line. Okay. Kenapa kita perlukan ni? Kita nak dapatkan, remember, we need to find the theta tu. Berapa angle ni? Kita nak bagi tahu programming. What is theta n1? What is theta n2? What is theta p1? What is theta p2? Jadi, ini target kita. So, first kita dapatkan general equation for the line. And we need to understand that, okay, nampak tak tadi? Kita compare dengan sinusoidal signals kan. Right? We compare with the sinusoidal signals and this is always equal to kita kata and we know that MA equals to V peak M divided by V peak C carrier, isn't it? VM divided by VC. So, kalau kita fixkan nilai value VC to 1, maksudnya VM peak equals to MA. Betul VM peak, the amplitude of the sinusoidal modulating signals is always equals to MA if we set VC peak equals to 1. Nampak tak? Yang tadi kan kita fix VC ni equals to 1 value. Value dia 1, isn't it? Kita fix dia equals to 1. So, therefore, kalau kita tengok betul-betul equation untuk sinusoidal signals, okay, the sinusoidal signals, let's say we name it as a VM T equals to MA sine omega T and K plus 1. Right? So, ini equation untuk the sinusoidal signals. Ini sebenarnya V peak M, where VC equals to 1. Isn't it? That's why kita ada MA je terus kat sini, MA sign. Ini kita nak dapatkan apa? Bila kita, remember, if we want to get the point T and 1, we must equate, isn't it? We must equate the sinusoidal equation with the negative slope, the first negative slope equation. Then you can find the T and 1. Isn't it? Next, you equate the same sinusoidal signal equation with the positive slope equation. Then you akan dapat TP1. Okay, itu yang kita buat di bawah ni. Right? Ini yang kita dapat untuk equation yang first, untuk negative slope equation. So, ini dia punya equation dia, TMK1. And then, ini untuk dapatkan equation ataupun di zero crossing, ataupun kita nak dapatkan point tadi, TN1, TN2, apa tu, kan kita nak cari. Sebab we know that theta equals to omega T, isn't it? Kalau kita nak dapatkan theta 1, kita multiply dengan omega T1. Right? So, you akan dapat dia punya theta equals to theta 1 equals to omega T1. So, omega ni sebenarnya omega apa? 2 pi F. And F ni sebenarnya F, which is the slow frequency 50 Hz. 2 pi F 50 Hz frequency, bukannya yang carrier signals tu. Jadi 50 Hz frequency. 2 pi F multiplied by T. Okay. So once we have this equation, then kita boleh carilah. Kita boleh cari apa TM1 gunakan calculator. Ini tak boleh solve. Dia requires a calculator, complex. Dia macam yang kita cari apa beta baru ni tu. Kita kena solve gunakan function dalam calculator untuk dapatkan value-value theta. Okay, so I hope you clear with that. Kita ada T1. Ini example dia. Okay, kita boleh go through. Tak apa, nanti saya share ada satu example tu. Saya nak cari. Okay, saya fokus on the explanation dulu. Okay, 6 pulse, 8 pulse. Okay, kemudian kita pergi ke bipolar PWM. Yang dia punya apa example nanti saya share dalam WhatsApp. Okay, untuk bipolar PWM dia slightly different. Okay, slightly different. Look at this. Bipolar, remember kita compare the triangular carrier signals, but now it has positive and negative value. Okay, positive and negative value. So normally it start with a 0 levels here. Okay, selalunya akan start at 0 levels lah. Dia tak macam unipolar tadi, ada M shape, V shape, M shape and W shape. Okay, dia ada memang akan start dengan 0. 0 triangular carrier signal, positive negative value. Okay, ini pun sama juga. First you start with TP1, isn't it? This is positive line, a positive slope triangular carrier signal line. Tapi definitely kalau you tengok ini TP1 equals to apa? Betul-betul kat 0 ni, isn't it? So tak payah cari, tak payah ni, TP1 is always 0, isn't it? Definitely TP1 will be equals to 0. Okay, tapi kita tengok TN1. Okay, TN1 right dekat sini. And you kena faham sekarang. Right? TC dia, kalau you betul-betul sini, tengok saya tanda betul-betul dia TC ni yang kat sini ni, dia start dengan sini tau. Dia start dengan situ, dan dia sampai ke sini. Itu dia punya TC yang ditunjuk kat situ tu. Okay, so you boleh shift sebenarnya. You boleh start dekat sini sampai ke daripada sini sampai ke sini kan. Boleh juga. Maksudnya you start daripada sini. Start daripada kosong. Boleh juga. Tak ada masalah. So, gunakan tu sebagai TC. Boleh juga. Okay, itu dia punya TC. Ada the period of the carrier signals. Alright. So, you analyze balik betul-betul. It's self-explanatory. Saya tak perlu go through betul-betul. Okay. So, Y equals to MX plus C. So, now, kalau you tengok betul-betul, delta X dia, delta Y dia 2. 2. Yes. Okay. Kalau you tengok ini, daripada sini ke sini, delta Y dia equals to 2 minus 1, 0, 1, so it is 2. Dan kalau you tengok daripada sini ke sini, okay, dia separuh, isn't it? Separuh of TC. So that's why delta X equals to TC over 2. And that's why you punya M equals to 2 over 2 TC. M equals to 2 over TC over 2. And finally you have M equals to 4 over TC untuk first positive slope. And then you dapat YP1 equals 4 TC over T. And then next untuk negative slope, you akan dapat negative. Then finally you have these two. Buat lagi proceed with the second slope, second positive slope. You akan dapat ini, you akan dapat ini, and go further, and finally you can generalize. Generalize the equation, you akan dapat ini. YPK part 1 equals to 4 over TCT minus 4K. And then for the other negative slope, it is minus 4 over TCT plus 4K plus 2. Okay? Right. Therefore, then again you equate with the sinusoidal signals. sinusoidal signals, then this is the final equation that you must remember, you must understand, you must uh, use in calculator to find the values. Theta 1, theta 2, theta 3. So kalau kat sini, kalau nak dapatkan, kalau kita nak suruh carikan theta n1, macam mana? In terms of radian. So apa-apa start with the radian lah, senang. You cari dalam bentuk radian, and then you convert into degree. Tapi start with the radian. Okay, so kalau nak dapatkan tu, you just multiply, isn't it? Omega Tn k plus 1 equals to, di sini pun you kali dengan omega. So, jadi omega Tc over 4. What is omega? 2 pi Fm. The moderating signals ni. Yang 50 Hz. Fm. Okay, bukannya FC. Ini is Fm. Right? So, you dapatkan ni. And then, kat dalam ni, kita tengok betul-betul, ini dah jadi apa? Kita pindah. So, equation ni kita tengok betul-betul. So, kalau saya multiply dengan omega, multiply by that, and then on the left, on the right side, omega multiply that, and then you dapat theta n k plus 1 equals to 2k plus 1 minus ma sin, ini akan jadi apa? This is also theta, isn't it? And that also, change that to theta n k plus 1. Then close bracket, and then you have this omega Tc over 4. Right? Tc over 4. Omega Tc over 4. Then kalau nak cari theta, katakan nak cari theta n 2. Therefore, k should be equals to 1, isn't it? Therefore, this equation becomes 2 multiplied by 1 is 2 plus 1 is 3. 3 ini jadi 6. 3 multiplied by 2 will become 6 minus whatever MA is sin N2 2 pi Fm over 4, and this is 1 over Fc. Right? Itu je. So, of course, equation ni tak susah nak solve. Ni kan sebab ia ada sign in. So, gunakan solve pada equation dalam calculator. Jadikan ini sebagai unknown. Equal sign. Then you do that and solve. Okay. But, of course, you need to have the initial value. Remember? If you punya initial value tu kena tepat lah. Kalau start, let's say, you kena estimate sikit. For example, this is 180 degree. Kemudian you ada 90 degree. So, you tengok ini berapa ni. For example, ini dekat 20 degree, for example. So, you can start initial value dia. Initial value. Dalam calculator, remember? Dalam calculator kan kena letak initial value. So, you convert that 20 degree to radian berapa. Convert that into radian. So, masuk, you akan dapatkan value. Berapa. Okay. Satu lagi. Dia dipanggil frequency ratio. Frequency ratio or known as FR, and this is FC divided by FM. Okay, so kalau kata dia FC is 2000, then your FM is 50 Hz, always 50 Hz. So kita ada berapa? 40, isn't it? So your frequency ratio is 40. Tak saya ingat sini ni. Saya nampak ni value ni. So that is known as frequency ratio. Okay, so sedikit sebanyak saya dah over 1 hour. Kita tak boleh lebih lama-lama dah. Okay, tak apa, no worries. Saya akan bagikan apa nama, you boleh tengok ada tak sini. Solving, ini ada solving for switching angles using FX50 Casio calculator, ada sini. You boleh try. Ini ada apa, some equation. Try kat sini. Cari. Okay. Claim membership. Kita dapat okay, semua dekat sini. Cuma yang proper equation je, proper questions on the PWM. Right? So, itu je. Any questions? InsyaAllah by tomorrow, I will pass the test 2. Okay. Back to you. So, is there any questions before we end this session? And next week, if you want to have we try to have another session next week. What's the revision week? Bila-bila. Whenever you're free.
What day, sir?
Okay, Faiz. Yeah.
What day will we have revision?
Can we maintain on ni boleh tak? Thursday boleh tak? Kan? Is it okay?
Thursday.
Yes.
Class time or earlier?
I don't know. Do you prefer 4 o'clock or what?
Could go a bit earlier because we don't have anything else throughout the day.
Alright, great then. So, tak apa, yang tu we're going to discuss on through the WhatsApp again. Alright? So we discuss on the WhatsApp on the time. So we maintain on the Thursday. So I hope I can receive a question from you, and then I try to share wherever I can for the final exam, final assessment. Okay?
Okay, sir.
Okay, sir.
Okay, thank you. Alright, good. Okay, so we end up our session today, and we see you again next week, inshallah. Okay, Assalamualaikum warahmatullahi wabarakatuh. Thank you. I will share with you the video.
Thank you,
Okay,
sir.
bye.
Thank you.
Thank you,
Thank you.
sir.